Hello, converting one-digit repeating decimals. All right, first thing we have to do is we have to let x equal 3.1 repeating. What we need to do is get rid of the repeating decimal part, okay? And to do that, we're going to go through a couple steps of solving equations. Remember, what you do to one side, you must do to the other, da-da-da-da. Okay, the x is equal to the 3.1%. So if I multiply both sides by 10, I get 10x is equal to 31.1 repeating. Remember, it's the 0.1 repeating forever. Doesn't matter if I multiply by a million, it's still going to be 0.1 repeating. Okay, but what I have now are two expressions that are equivalent, and I can subtract this whole thing from the one underneath it, and what will happen is my repeating decimal part will go away. That is the whole purpose and the whole point of what I'm doing. Okay, so I'm going to subtract x, and on the right side, what is x equal to? Well, that's equal to 3.1 repeating. Okay, so 10x minus 1x is 9x, and then 31.1 repeating minus 3.1 repeating. So I'm really just doing 31 minus 3, which is 28. Now I have 9x equals 28. I do not have a repeating decimal part. Now I just divide both sides by 9, and I get x is equal to 9 times 3 is 27, with 1 left over. So it'll be 3 and 1/9. Or you could have left it 28/9. So you have 28/9 or 3 and 1/9, either form. Let's take a look at another problem. This one is 2.5 repeating. Remember, x equals 2.5 repeating. This next step, the question is, well, how do you know if you multiply both sides by 10? How do you know if you multiply both sides by 100 or 1,000 and so forth? The key is, what is given is the 2.5. What do I have to multiply 2.5 to get the decimal point to the end of the number? And to do that, in this problem, I only have to move it once, so I multiply by 10. So I get 10x is equal to 25.5 repeating. Now I can subtract my original number. I can subtract x on this side. And what is x equal to? X, remember, right above it, is equal to 2.5 repeating. I can subtract now. 10x minus 1x is 9x. And then 25.5 minus 2.5 is 23. Divide both sides by 9. My answer is 23/9. You could write it as a mixed number, and that would be 2 and 5/9. All right, let's take a look at another problem. Uh-oh. This one's x equals 1.83 with a bar over it. Remember in the last problem I said, well, do we multiply by 10? Do we multiply by 100? What do we do? In this problem, we are going to multiply by 100 because I want to get my decimal point to the end of the number. So to do that, I have to multiply by 100. So I get 100x is equal to 183.3 repeating. Okay, now, the next step here, people always ask, well, Mr. Eltzville, why did we do it that? Well, what are they talking about? I want to be able to subtract something here so that I am subtracting just the 0.3 repeating part. Okay? To do that, in this part up here, if I use 10x equals 18.3 repeating, notice that I have just my 0.3 repeating part when I multiply by 10. So what I'm going to do, I am going to subtract 10x. Okay, well, what does 10x equal to? That's equal to the 18.3. 18.3. And when I subtract, I get 90x is equal to 165. My 0.3s cancel each other out when I subtract them, the repeatings. Okay, so then I divide by 90x. Excuse me, I divide by 90, sorry. And then I divide by 90, and that is equal to 5 goes into both 165 and 90. 5 goes into 165 33 times. 5 goes into 90 18 times. 3 can go in again. 3 goes into 33 11. And 3 goes into 18 6. So you get 11/6 as your answer. Rewriting as a simplified fraction. So remember, the first step I did is got the 100x because I needed to take it times 100 because I needed to move it 2 places. Okay, the second thing I had to do was figure out what can I subtract. Well, I can subtract this so that my 0.3s cancel out. Let's take a look at another problem. All right, here's a similar problem to the one we just did. So let's see if we can work through it. Now, remember, you are supposed to be pausing, doing the problem on your own, and then seeing if you get it correct. So x is going to equal 2.01 with a bar over it. To get the decimal point to the end of the number, I have to multiply by 100. So that'll be 100x is equal to 201.1 repeating. Now I have to subtract a 0.1 repeating. To do that, I have to take the original one and divide or multiply by 10, so I get 10x. And when I multiply the 2.01 times 10, that is going to be 20.1 repeating. Now the 0.1 repeatings cancel out. They'll go away. 100x minus 10x is 90x. And 201 minus 20 is 181. Now I divide both sides by 90. Divide by 90. And we do not have a common factor. There isn't a number that goes into both 181 and 90. So the answer is 181 over 90. All right, let's take a look at another one. All right, now notice this one has 3 decimal places. Because it has 3 decimal places, I need to multiply by 1,000. But before I do that, silly me, I need to let x equal 0.416 with a bar over the 6. Now I do the 1,000x is equal to 416.6 repeating. What am I going to do so that I can multiply the 0.416 by so that I get just the 6 repeating? So what I want, if I look at this number, I want 41.6 repeating. That way my 0.6 repeatings will go away. Well, to get 41.6, I must multiply by 100. So I'm going to use 100x is equal to 41.6 with a bar over it. Now I subtract 1,000 minus 100 is 900x, and that will equal 375. Double checking, 6 minus 1 is 5. 4 from 41 is 37, so I get 375. Now I divide both sides by the 900. Divide by 900. And both numbers can be divided by not only 5, but they can be divided by 25. So there are 12, 13, 14, 15 quarters in 375. And 900 divided by 25. There, I think we have 36. I'll have to double check that. 3 goes into both of them. 3 goes into 15 5 times, and 3 goes into 36 12 times. So we get 5 12ths. The 36 part I got to double check. Yes, and since you have a calculator, you've already discovered that that is correct. So we get 5 12ths as your answer. All right, let's take a look at another problem. Oh my goodness, we're done. We're done already. Holy cow. Good luck.